Hi everybody, it's Dan from the House of Broken Dobbs Things. Shooting a little quick video here. We've finished up the reverse mount parting tool with good success, I think. Got a few more tools, so we'll show you a few more things on that later. But tonight's project is a quick one, I hope. It's high time that I installed the tachometer for the mill, because it's like I'm kind of guessing. I mean, just when it feels right. May not make a big change in my life, however, I need to install it. So what I have here is the top off of a pre-built project box. I could print one, but it's like, I already had this, so let's not go nuts. Okay, so from that one, the tachometer assembly, it's right here. It's a pretty tidy unit. Uses a Hall effect pickup, little magnet setup, nice one. This was first shown to me on Randy Richards' channel. He did this one. I've had it on the shelf for quite a long time. I powered it up the other day on the bench just so I could see if it worked still. I had a little 12-volt power supply all set up for it, so got that done. So what we're going to do is we're going to set this into the face of this project box top. We're going to try to do it nice and neat, and we're going to try to use the DRO to do it with. So not as nice a project plan as others, but I did spend some time rather than go off half talk like I normally do. So don't worry about this. There's the top of the project box. Inside you've got some corner edges that I want to avoid. Right here where the screws go. Right from there, and there's also an inset on the inside of the lid that you can't see from this angle right here. And that's what I've got drawn over here. So there's an offset, it's 84.45 to the clear of the inside reinforcement. This is 4 millimeters wide going across that little bit. So 158, 80, I'm using millimeters here. I know, what are you doing, Dan? Yeah, I'm using millimeters, it's kind of fun. And then down here I have 135.36 to be clear of everything. So the project plan is, I'm going to come in and pick up this end here. I'm going to pick up this edge here, and then I'm going to be able to drive right to where I want. So I want to go 8.15 millimeters in, which is going to give me the half of the section here where I'm going to come in and put the tack lead. So the 8.15 is going to be here. I'm going to add 4 millimeters, so it's going to wind up being 12.15 because of the thickness of the case. So I'm just going to edge find off the outside, knowing fully well that there's this insert in here. So we're just going to come in 12.15 here on each side. That's going to get us our center. And we're going to come down from the top 25.4. Let's make that 29.4. We'll bring in that one. Okay, let's bring that in 29.4. And that should set us about an inch down. 29 will give us an inch clear of that internal edge too, and it should put us roughly in this vicinity. That's quite a big box for a little tachometer. I know, but I might be able to add something else in there. I have kooky ideas occasionally, but anyway, that's what I'm going to try to do tonight. So hang in there. This is kind of just a quick sketch of the tack. Now they give you this, say it's 70 millimeters by 36. Yeah, that is the outside shell of the tachometer. Here, that's the outside shell on the outer edge. But what you have to factor in is this little inset where these little clips are going to grab the top of the project box, but you're going to have to come in to this amount here. Otherwise, you're going to have a gap around the outside edge if you use the 36 and the 70 that they gave you in the schematic. So, what are you talking about? Right here. They gave you 70 right there, plus or minus a tenth, and then they gave you 36 right here, plus or minus. So we're going to go ahead and go from there. Hopefully you're going to see a little bit of improved video here. I did add a light on top of the iPhone that I'm using here with the tripod. Hopefully that came out pretty well in the last video. Trying to use the tripod to get rid of the shakes because I know it's annoying just like everybody else. So from that standpoint, we'll get started here. I'm going to start off finding those edges. Well, that's a great idea, Dan. How are you going to find the edge when you got that set below? You're right. let me go find my setup blocks and get a little taller in there. I've got some parallels sitting right here. I'll bring you back. Okay, let's pick up this edge on the y-axis. Yeah, that should be all right. All right, let's 0 to Y. And 0. And come around. And 0 on the X. The vise is still square. You see that okay? All right, here's the X. Okay. So, I crank out here. 0. Okay, welcome back. It's been a bit. We had a small hiccup with one of my DRO scales, operator install error. Not a big deal. But from that one, back going again. We are working on the top of what's going to be the tachometer housing. There we go. And what I want to point out is I'm using Touch DRO. And again, probably not absolutely the the most correct way. However, let me just show you what I've been doing. I edge found on the actual part and set up the top, set up the corner, and then came down to the sizes that I wanted. The scales reference, it really doesn't matter right now, but what I was able to do was when I got to the certain points that I'm looking for, I was able to go ahead and right down here add a point. So I have a clear workspace and so forth, but adding a point. So here, and here even within the point, I'm able to describe it by adding a text of top left corner, and then right hand top corner, right hand bottom corner, and left hand. So what it actually was I hit the corner, well, let's just change that to something that's viewable for you. Everybody. Again, that's something else. So I started in this upper corner right here. Edge found this, came down a certain point, came over a certain point. This is the top left-hand corner point, and so on and so forth. So, and then I just took my machinist square and just kind of sketched that in just so it looks reasonable. And then from the reasonableness that we looked at there, then I just double check before I ruin this case, double check the size, and hopefully you can see that pretty well. Right about there, it's in line all the way around the outside. So I think we're in pretty good shape. Let me come down just a little bit here. You see that one or not? Right here, little bitty end mill right there. If I were to put a dimension on that poor little thing, it would be quite small. I put my calipers. Why are the calipers always gone? They're always gone. Okay, here they are. Safe and sound on the bench. So just to give you a rough sketch. Again, not going for precision here. About a 1.5 millimeter. So very small, but I'm going to do my first setup on that. I'm going to let the technology take me where I need to go. So these points are remembered. So I'm going to just do a test here. Top left-hand corner, 142.77 away, and 33.23 millimeters away from that point. That point will be this left top corner. I'm looking at this as being the top end. Okay, let's drive there and see if we're halfway even close. I'm going to do this before I ruin the part. And you know it's active because it's lit up in green. Okay, let's bring that down. And I did turn on the data filters in case Yuri, the inventor, ever sees this video. All right, so that is setting my X. And then let's come in with the Y. Come here, Y. Okay, there's the Y. We'll lock that one. Now, come just a hair, set up the shot. That's one of my other projects. So I'm going to basically break the spindle loose here. I'm going to drop that little bad boy right there. If you can see that, and again, sorry about the focus. Right there, there's the line, there's the line, and it dropped that one right dead center on where that point was. Okay, I know I'm going around the bend for some of you, but some folks that are brand new, like me, might say, well, that's kind of cool. Yeah, all right, so I'm gonna go on over to the right-hand corner. It's 68 millimeters, okay? So let me back this out here. I just went to the right-hand top corner, 68 millimeters. Obviously it's on the same plane, so shouldn't be any up or down from there, but I'm gonna bring it in and drop that point and see how close we are. The reason I'm doing this kind of carefully is that little tachometer part that I've got, it has almost no room for error. The little shroud that goes around it, it's just not much. All right, so we'll drop that one right there on that point. You can see that. I'm going to try a different little lighting here. Hopefully you can see that. There's white to help block it off. Yeah, you can see right there. So I dropped it right on that point. Okay, take this up. I'm going to go to the right-hand bottom corner, which is going to be on the same line as this one was. So we're going to crank that one down. Trust me, folks, from starting out with dials, this is really pretty darn cool. All right. We get the general idea. And again, my pencil marks were not absolutely precise either. You can see it's dropping it right on that mark. The pencil marks probably have more error than the scales do. Okay, so we have that one. Now I'm going to go to the left-hand corner. Okay, and scroll it back. It said 68 too, by the way. Sorry, I didn't zoom back out so you can see. It was 68, so just to be fair, let's go back to this point. See, there's no harm there. Just go right back to it. It's like, oh, okay. So once you get the initial points set, it's like, well, you can do whatever you like. Okay, there, give or take. Okay, now I'm going to go to the left-hand bottom corner. There's the 68 I mentioned a while ago. Crank that bad boy. Okay, and if we drop that one down, we're going to be dropping right on that one. See that? Yeah, here's my pencil mark right here. And there's the line going across, so. Sorry, it just seems to be having a hard time focusing in that close, so. Okay. Now, what that shows me is that I basically have made a square, rectangle if you will, and the points are recreatable with some precision. That's why I used that little bitty bit, so you didn't have this big blob of end mill, like trying to drop this guy on top of that line. Well, where is it? I don't know. It's somewhere underneath there. So long story short, we're going to start to mill that out, but we were able to recreate it. We were able to use the set points on Touch DRO, and it seems to be working just great. I didn't play with the tool offset. I'm going to bring that in later, but as of right now, I'm going to go ahead and mill this out as is. We'll see how that little end mill likes it. I don't think it's going to, because plastic is kind of weird stuff. But we're going to go ahead and mill that out. All right, we'll bring you back. All right, I'm going to go back to the top left corner. I inset that 0.86. As I mentioned, I wasn't going to use it, so I'm just to give myself a little room for error. But 33.25. I'm going to be traversing here. Really slow in the plastic. And I've been locking the axes as I go. I'd really rather not break this little end now. I got it before all the inflation hit and prices went way, way, way up. And you could buy these in a lot off of eBay for, $10 for 10, like $1 a piece. And around in the US, a lot of the job shops, when they're done with a production run, to be compliant with their ISO standards, they take all the tooling and they scrap it. And if they have to do that to be compliant. I'm getting a little wiggle out of the plastic, so I'm going to give it some support. And part just fell out. So we were right at milling that corner. There just wasn't enough to hold it anymore. Okay. So clean up. Looks like we cut a rectangle, gang. That's cool. We're doing it manually. I'm not sure I would have lined up even close to that. So, to those of you who are watching the previous episode, when I grabbed this great big behemoth extra milling vise that I had, I like this thing. Yeah, it's sitting sideways. It's way too big for this mill, but darn it, I like it. Here's our work product. you know what? I don't see anything wrong with that cut we did. Wrong end mill, whatever it was, seemed to work. Now, I had planned for this thing being a little tight, okay? Just because I have a tendency to overshoot the runway when I'm cutting, so as has been noted, you can't put the plastic back, okay? Looks like I am just a hair shy. That's okay. Because here's the reason why. This little ledge, it's not much. So I will probably going to take my little Noga deburring tool and work that edge ever so slightly. Just, you can see that? You're probably 1/2 millimeter or so from that going straight through. So that's going to be okay. I'll bring it right back. Okay. This is my Noga like. My Noga one's in the house, but this one is from Chevy, maybe there? I don't know. Maybe there? I don't see Noga anywhere on it, but it's sure just like the Noga one. But what's nice is you do this somewhat in 3D printing too. I mean, that's a very nice fit. But these are good for deburring metal. They are also really good for shaving plastic ever so slightly. I mean, I didn't have much to get, but that is a beautiful fit now compared to what I would have done with dials. Oh my gosh. Okay. And I've got to pop the little clips in. These guys right here, but there's not a thing wrong with that one. That's a success. Again, going back to the plastic, the cut, we got a little feathering, but you know what? Just going slow. I had that end mill going. Did a pretty nice job. Just because I know some folks are watching. Outside of that little corner booger, I'd say that's fine. Hey, Dan cut a rectangle. Trust me, folks, it's been a long road to Jericho here. So I will get that in and I will bring you back. Okay, for those of you that are watching, that fit on the inside, wow, I am extremely happy with that. No hogging, no gaps, no light, no nothing. That is a great fit. Everybody's sitting flush. Wow. My days don't always wind up like this, as you know, on this channel, but that's step one. The wiring on it is pretty straightforward. This is a tachometer kit, just going back to that. Kick the camera, Dan. People like that. Okay, here's the magnetic pickup. And it sends out I think I measured it like a 4 volt signal, thereabouts. There's a magnet. Come on, there you go. A very good magnet. You can hear it clanking around over there. So from this one, there's your magnet. So that's going to be mounted on the spindle of the machine. The reason on the spindle, because that will go ahead and take care of the belt ratios on this one. I have 1, 2, 3, 4, 5 pulley combinations in there. So that's quite a bit. So I'm going to go ahead and put this directly on the spindle. So that's going to take out the belt position and give me a direct idea where it is. I have a variable frequency drive, so I can vary the speed even a little tighter from that. But at the same time, that was pretty nice, actually. I mentioned that this one has a seal on this box. You can see it. It's already set in there. You basically just cut it to length, press it into place. It looks good. So we are going to set up and get this attached, but I wanted to get that milling done because I'm setting myself up for disappointment because Stuff doesn't come out straight like that often. But I'm glad I took extra time, and I'm really glad I had the Touch DRO to set those points, because that really made it simple. And just remembering, again, I'll play with the tool offset, but this was a simple, it was a 1.5 diameter tool, so just basically took 0.75 and I threw a 1/10 of a millimeter in just for slop. And that's probably what it was dimensionally, where I needed it to come through and trim it back ever so slightly. But man, that's a great fit. I'm happy. All right, I will bring you back. We'll get closer.